Good afternoon, everyone. Thank you for being here today. Today, I'll be presenting our research titled Understanding the Impact of an Active Exoskeleton System on Vigilance Level of Workers During Common Repetitive Construction Tasks. My name is Amit Ojha. I'm a PhD candidate in Department of Civil and Environmental Engineering at University of Illinois Urbana-Champaign. So I'm presenting this work, which is done in collaboration with my colleague Yogesh Gautam and my PhD advisor Professor Houtan Jebelli from University of Illinois Urbana-Champaign and Professor Abiola Akanmu from Virginia Tech. Let's begin by highlighting the broader motivation behind this study. So the construction industry is one of the most physically demanding occupational sectors. Workers frequently perform physically intensive tasks that involves repetitive lifting, awkward postures and prolonged physical exertion, often in awkward postures. As a result, work-related musculoskeletal disorders or WMSDs are highly prevalent in construction industry. So if we look into the data, according to the Bureau of Labor Statistics, WMSDs accounts for approximately 37% of all non-fatal injuries and illness in the construction workforce. Financially, this translates to over $400 million in workers' compensation claims annually. But beyond the cost, this WMSDs impacts worker health, job site productivity, and long-term labor availability. So these persistent challenges of WMSDs has motivated the exploration of new technologies, new emerging technologies aimed at injury prevention and mitigation. So one promising technological solution to alleviate the risk of WMSDs from construction workers is the use of wearable exoskeletons. So basically, wearable robots, also known as exoskeletons, are robotic assistive systems that are designed to reduce the strain on worker musculoskeletal system by providing mechanical support during physically intensive tasks. They are increasingly being studied in domains like manufacturing and logistics, and more recently they are being studied in our sector, construction. So there are different types of exoskeletons. Our focus here is on active exoskeletons. So active exoskeletons are those systems that are powered by actuators such as electric motors, pneumatic motors or hydraulic motors, and unlike passive exoskeletons that rely on elastic elements or mechanical springs to provide postural correction and weight dispersion, active exoskeletons provide active lift support. It adjusts to the user motion, delivering support when and where needed, and they are capable of real-time lift assistance, load dispersion, joint stabilization, posture correction. However, this complexity brings forth a crucial concern. Does the experience of wearing and operating such a system by wearing it can affect a worker's vigilance and attentional capacity? Let me elaborate on why vigilance is a crucial concern. On a construction site, maintaining constant situational awareness is vital. Workers must remain alert to hazards such as moving machineries, falling objects, or unstable surfaces. If the exoskeleton imposes new cognitive demands, the case in point here is active exoskeleton, whether due to discomfort, operational complexity, or simply unfamiliar physical sensation, it could divert attention from the environment and compromise the safety. Previous literature has explored the biomechanical and ergonomic impact of exoskeletons, but the cognitive dimension, particularly vigilance, remains underexplored. So this is the knowledge gap that our study aims to address. So basically what we can say is that the current body of knowledge does not provide a comprehensive understanding of the impact of active exoskeletons on the worker's vigilance level, which may lead to improper use or underutilization of active exoskeleton, negating their potential benefits. So in summary, our problem statement is as follows. Despite the growing integration of exoskeleton into the construction sector, there is a lack of comprehensive understanding of their impact on workers' vigilance level. So to address this, our research objective is to evaluate whether wearing an active exoskeleton alters vigilance level of construction workers while performing common construction activities. So to investigate this, to investigate the impact of active exoskeleton on workers' vigilance level, we designed a two-step methodology. So in step one, which is a virtual testbed development, we develop a realistic immersive testbed simulating a common material handling task, that is lifting and carrying concrete blocks under two conditions, with and without the use of active exoskeleton. And in the step two, we quantitatively assess the workers' vigilance level by analyzing the eye tracking metrics collected from the predefined areas of interest within that developed virtual environment, corresponding to both with condition and without condition. So this approach of using the virtual environment allows us to control for the task complexity, environmental distraction, and collect fine-grained attention data in a repeatable, ethical, and a cost-effective manner. So talking about the step one of our methodology about the virtual testbed development. So the virtual job site was modeled using Autodesk Revit, and it was integrated into the Unity, forming an interactive and immersive VR scenario. So a virtual representation of active exoskeleton was integrated into the virtual environment. The participants wore a VR headset and then interacted with the tangible interface. So here the tangible interface was of the brick, the concrete block, and the exoskeletons. So it replicated the real world lifting and movement, and also the feeling of active exoskeletons. We also digitally integrated a virtual representation of the active exoskeleton, so the users could experience the sensation and restriction of wearing one during the task. And the core tasks involved lifting a 10-pound concrete block, navigating in a iron beam, and placing the block in a designated location while working at a simulated height to increase the realism. And importantly, we also predefined the areas of interest in the virtual environment corresponding to the potential hazards such as edge, drop zones, and obstructions. So after we developed the virtual test environment, this is the step 2 of our methodology where we assess the vigilance level. So for this, we recruited 18 subjects. You can see the average age, average height, and average weight in the slides. So these subjects were asked to perform the material handling tasks with and without wearing the active exoskeleton in the virtual environment. So while they were performing the tasks, the fixation count and fixation duration were collected from the AOIs from each subject during both conditions. So talking about the result, when using the active exoskeleton, the average fixation count is 59.85 and average fixation duration is 43.8. Similarly, when not using the active exoskeleton, the average fixation count is 54.35 and average fixation duration is 39.85. So you can see there is not much difference in fixation count and fixation duration. So to statistically evaluate it, we ran a man-widely U test at a 0.05 significance level, and the result also showed no statistically significant difference in either fixation count or fixation duration. So what we can say is that wearing an active exoskeleton did not measurably alter the workers' visual attention to hazard or reduce their vigilance during the task. So these findings are meaningful because while the exoskeleton physically augment the worker, they do not appear to impair the cognitive vigilance, at least under the controlled condition of this study. So talking about the conclusion, we evaluated the impact of active exoskeleton system on vigilance level of construction workers during common construction tasks, and the results suggest that active exoskeleton did not distract workers or negatively impact the user vigilance level. Some of the limitations of this study must be acknowledged. So one of the limitations is that study was conducted with a relatively small sample size, and also the VR cannot replicate the complexity of real world construction sites. So this limitation can be addressed in future research. So future studies can be done with a larger or more diverse group of participants. Also, the future study could validate the findings in actual construction settings to provide a more comprehensive understanding of how exoskeleton impact vigilance. So lastly, I want to acknowledge all my colleagues at RAISE Lab and the funding agency. Thank you everyone.